Matthew and Chase, good afternoon, good morning, whenever you're listening to this video. I do apologize for missing the weather completely. When GPS canceled their afternoon activities in Hamilton County and Ringgold schools all let out half a day, it really sounded like we were going to get some snow. So I apologize, but I did not want to take a chance, with you guys being stuck here and safety issues and stuff like that. So I do apologize. This video, hopefully you should listen to this before Monday's class. A couple things, an email that I sent your parents. I have an attachment to that email. So if your parents have not ran that copy for you yet, you need to pause the video now and get the handout, okay? It's a small 2-page handout, just like we always have in class. You can punch some holes in it and put it in your notebook, but you really do need that before you start the video. So if you've not done that, pause it, and we'll go from there. Okay, like we always do, we review. We review the last 2 things, or the last 2 days of material. So here we go. Let me tell you my philosophy on videos. I go really fast because you can always slow me down by pausing the video or rewinding it, but you cannot speed me up. And so I'm going to go pretty fast, and you just pause the video and rewind it when you need to, okay? All right, here we go. Let's very quickly review factoring. So if I gave you this trinomial right here, notice it has a lead coefficient of 1, or we say it does not have a lead coefficient, or it has a lead coefficient of 1. That's the easy type of factoring. So the first thing, and again, you probably don't need to take notes on this. If you were at my house, you would just watch me go through this just to refresh your memory. But if you want to take notes, that's up to you. First thing we do is we list out all the factors of -6. So there they are off to the side. Then we look at these factors and we pick one that adds up or combines to the middle number, which is -5. And of course that would be those 2 numbers right there. Those 2 numbers combine to give you -5. And then next you simply write your parentheses. So there's your answer. You have successfully factored this trinomial right here, quadratic trinomial, that had a lead coefficient of 1. Now let's factor one that's more difficult. Let's factor a trinomial that does not have a lead coefficient of 1. So here it is, and you should know by now you take this first number, the lead coefficient, and the constant term, and you multiply them together. That's where this 60 came from, and then you list out all the factors of 60. Now you understand that'd be 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. That's a big list of numbers. Okay, so instead of listing out all the factors of 60, I'm just going to show you the ones that would work. Okay, there it is right there. If you listed out all the factors of 60, these 2 numbers right here are factors of 60, but when you combine them, you get a -19. Okay? Do you see that? Now a lot of students are like, oh, I know the answer. It's x minus 4, close the parentheses, x minus 15. And that's incorrect. You only take these 2 numbers here and write them in the parentheses when you have a lead coefficient of 1, and we don't have a lead coefficient of 1. So what we do is this. Do you remember what to do? We bring down the 10x squared, we bring down the positive 6, and see this -19x? It's gone. And in place of that, we took these 2 numbers right here and we put an x with them. Why did you put an x with them, Mr. Earhart? Well, because there's an x right here. So a -4x and a -15x. And then what I've taught you guys to do is to look at the first 2 terms, okay? So we've talked about this. If you look at just the first 2 terms right here, what number goes into 10 and 4 evenly? 2. And you've got 2 x's here and 1 x here, so you pull out 1 x. 10 divided by 2 is 5. 2 minus 1 is 1 x. -4 divided by 2 is -2, and there's no x. And then we look at these last 2 terms right here, these 2. What number goes into 15 and 6 evenly? Well, 3 does. And whenever this term here, the first term that you're looking at, in fact, I'm going to go ahead and do this, and I'm going to go ahead and do this. I hope I'm not annoying you, but I really want to make sure you get this. When you look at these second 2 terms right here, Notice there's a negative sign here, so you do pull out a negative number, okay? Both of these terms did not have an x, so you don't pull an x out. So a negative 15 divided by a negative 3 is a positive 5 with an x. 6 divided by negative 3 is negative 2. And then if you've done everything correctly, your parentheses should match. And our parentheses do match. Here's 1 and here's 1. So the next step, remember what to do. You cross these parentheses off and you write that matching parentheses one time, and then look what's left over on the outside. That's what goes in the other parentheses, 2x minus 3. So it would look like that right there. Okay, all right, that's reviewing and factoring. Let's keep moving. Let's review. We talked about two words last class period, solving and simplifying. Now remember, you solve this if it's a perfect square, and trust me, 212 is not a perfect square. So we cannot solve this, we cannot, but we might be able to simplify it. Do you remember your perfect squares list? 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12. Now I'm getting a little sketchy here. 13 times 13 is 169. 14 times 14, I really don't remember what that is. I think it's 196 maybe. And then 15 times 15 I think is 225. These two I'm not sure about, but you can look in your notes. Anyways, if any of these perfect squares will go into this number evenly, then we can simplify it. Well, there it is. 4 goes into 212/53. And 4 is a perfect square. So what I taught you to do next was to cross off the 4 and pull out a 2, and you're left over with a 53. Now, Mr. Earhart, how do you know you're finished? Well, there are no perfect squares that will divide into 53 evenly, so you know you're finished. And again, you can rewind this. I'm going to keep moving. You can rewind that if you need to. All right, let's look at multiplying radicals. What I taught you to do was to multiply the outside numbers, 2 times 3 times 1, and get a number here, and then multiply the inside numbers and get a number here. Okay, so it should look like this. 6 square root of 96. And then you say to yourself, is 96 a perfect square? No, it is not. So we know we can't solve it. Cannot solve it. Maybe we can simplify it. Maybe we can't. Do any perfect squares divide into 96 evenly? Yes, 16. 16 goes into 96 6 times. So 16 times 6 is 96. And now one of these is a perfect square, of course, it's the 16. So we cross off the 16 and we put a 4 on the outside because the square root of 16 is 4. And then we go ahead and multiply the outside numbers. We end up with 24 square root of 6. All right, let's continue on. Now let's multiply some fractions. That's not too big of a deal. We should know what to do. I mean, we know how to multiply 15 over 7 times 4 over 3. If you do that correctly, 15 times 4 is 60. 7 times 3 is 21. Now, here's what we talked about during the last class that we met. Number one, I always taught you to reduce the fraction if you can reduce it, or if you have any perfect squares, to go ahead and solve those. Now, we don't have any perfect squares, but we can reduce this fraction, okay? 3 goes into both of these numbers. So let's reduce 60 over 21 to 20 over 7. All right, we have reduced it. Do you see any perfect squares? I do not. And so I don't have any perfect squares. So the next thing that I taught you to do is to split the radical up. Really nice radical there, huh? Split the radical up into two different radicals. And then we never want to have a radical in the denominator, okay? So next I taught you to multiply the top and the bottom by square root of 7 over square root of 7. That gives you square root of 140 over square root of 49. Now we got some perfect squares, don't we? Right there. That's a perfect square. And so next I would have 140 over 7. And now you say, well, Mr. Earhart, we're done. There's no radical under the denominator. True, but remember, students, anytime you can simplify this, you need to do so. Now, is 140 a perfect square? No, it is not. So you cannot solve it, but you might be able to simplify it. In fact, you can. 4 is a perfect square, and 4 goes into 140 35 times. So 4 times 35, and then we cross off the 4 and put a 2 on the outside. So cross off the 4, put a 2 on the outside. 2 square root of 35 over 7. Now, how do you know you're finished? Well, let me ask you some questions. Can your outside numbers reduce? No. Can you simplify square root of 35? No, there's no perfect square that goes into 35 evenly. And do you have a radical in your denominator? No, you don't. And so you are completely finished with this problem. All right, grab your handouts, please. And I want you to look at page 1. Again, I go fast, and then you can pause the video or slow down if you need to. So here we go. If you'll look at handout number 1, it says we are going to learn how to solve quadratic equations today. In the past, I'm just reading right here from the top of your handout, page number 1. In the past, the only type of equations that you have learned how to solve have been linear equations, and that's true. That's all that we've learned how to solve so far have been linear equations. Stuff like this. This should ring a bell. 2x minus 5 equals negative 3. X plus 4, all right? And you learned how to simplify that linear equation, take the negative 3 and multiply it through. And then you learned how to bring the 3x over. When you bring it over, it becomes a positive 3x. And you learned how to bring this negative 5 over and make it a positive 5, and that gives you negative 7, and then divide by 5. We've learned all of that, okay? And so now we're going to go on and solve quadratic equations. I'm going to continue to read from your handout. We're on page number 1. We will be learning 2 methods that will help us solve quadratic equations. The first method is called the factoring method. The second method is called the square root method. All right, if you look at your notes there, we are starting off with solving the quadratic equations by factoring, lesson 5.2. And if you'll look in your notes, you have this equation right here, x plus 2 parentheses, x minus 4 parentheses, 3x plus 5 parentheses. Now, before we attack this problem, I want you to watch something. You don't need to write this down, just watch. If I had 5 times 4 times 20, I'm not sure why my computer's messing up here. Hold on one second. It's kind of skipping a little bit. Times 15, and then put a blank right here, and then put times negative 6. If I had 5 times 4, that's 20. 20 times 20 is 400. 400 times 15 would be what? 6,000? Something like that, I believe. But then it really doesn't matter, because if I put this number right here in this empty parentheses, if I put a 0 right here, I don't care if it's 6,000, because once I take 6,000 times 0, I get out 0, and 0 times negative 6 is 0. In other words, here's what I want you to get. Are you listening? Whenever there's a long list of numbers that are being multiplied together, if just one of those numbers is a 0, the whole thing becomes 0. Now you might say, Mr. Earhart, that's pretty easy. We've learned that in elementary school. Well, I just want to point that out to you, because we're getting ready to use that in just a second here. Let me erase this. We're getting ready to use that in just a second on this problem. Look, students, notice my right side is equal to what number? 0. I've got a 0 right there. All right? Now, if I have a 0 right there, and I want to know what number, x, I want to know what number can become x that would make this whole side equal. What do I want it to equal to? I want this whole side to equal 0. If I can make just this parentheses become 0, then the whole side becomes 0. Or if I can make just this parentheses here become 0, then the whole side becomes 0. Or if I can make this parentheses become a 0, then the whole side becomes 0. So my goal is to simply, to put it in a nutshell, I want to know what makes each parentheses equal to 0. So I'm going to take my first parentheses, set it equal to 0, bring the 2 over and make it a negative 2, and there's one answer. And now I'm going to take x minus 4, I'm going to set it equal to 0, bring the 4 over, make it a positive 4, and there's another answer. And now I'm going to take 3x plus 5, and I'm going to set it equal to 0. All of this should be in your notes. You should be taking notes on this. It's all there in your notes. Bring the 5 over. When you bring the 5 over, it becomes a negative 5. And now we divide both sides by 3, which gives me a negative 5/3. Mr. Earhart, are you telling me that this equation right here has 3 answers? Yes, I am. This equation has 3 answers, and you do have to have all 3 of these answers in order for you to get the problem right. You guys know by now, you've come to my house many times, my boys are a little ornery and they are misbehaving, so I'm going to pause this video and I'll be back in just 1 second. Okay, so what I'm trying to show you here is if we can make one parenthesis become 0, or in other words, find the x value that makes that parenthesis 0, then we have one of the answers. So all three of these answers are right, and on a test or a quiz, you must get all of the answers, okay? So you say, well, Mr. Earhart, how in the world does this help me solve quadratics by factoring? Well, thanks for asking. I'm glad that you asked that question, and here we go. Please look at your notes. We're going to do those two problems down below that you see on page number 1. Before we do that, please look at the steps. We are going to solve quadratic equations by factoring. Now, step 1 says, make sure one side is equal to 0. If you don't do that, Matthew Chase, you're going to miss the problem. You must make sure one side is equal to 0. Number 2, factor one side. Factor it. And then step 3, set each group equal to 0 and solve each group. Okay, so here we go. Let's take a look at this first quadratic equation. Here's the quadratic equation that we are looking at, and we are going to solve that today. We are going to solve it using the factoring method. Okay, step 1 says make sure one side is equal to 0. Do we have that? Yes, we do. One side is equal to 0. Okay, step 2 says factor one side. Well, let's factor this side. I taught you how to do that about a week ago. I have a quadratic trinomial that has a lead coefficient of 1. This is the easy kind. So remember what to do. We're going to list out all the factors of negative 18. And students, I'm not going to take time and do that for you. I could put out a whole list. I'm just going to tell you right now the two numbers that we need are going to be positive 6 and negative 3. If you multiply those two numbers, you get negative 18. And if you combine those two numbers, you get positive 3. So I can factor this trinomial so quickly and so easily. The numbers that I want are x plus 6 and x minus 3. Now would you please look at your handout? Look at step number 2. Step number 2 said factor one side. Did I factor one side? Yes, I did. What does step 3 say to do? Set each group equal to 0 and solve. So I take my first group, x plus 6, and I set it equal to 0 and I solve. Bring the 6 over, make it a negative 6, and look at that. I have one answer. Now I take my next parentheses, x minus 3, I set it equal to 0. I bring the negative 3 over, it becomes a positive 3, and my answer is x equals 3. One word comes to mind. Cool. Very cool. Alright, so you just solved this quadratic equation by using the factoring method. Miss Sherrod, are you telling me if I put a negative 6 into all these x's, I would get a 0 out? Yes, you would. Are you also telling me if I put a 3 in all these x's, I would get a 0 out? Yes, you would. That is correct. These two numbers here satisfy this equation. Alright, let's try another one. If you'll look on your handout, you'll see this equation right here. 2t squared minus 17t plus 45 equals 3t minus 5. Now, if you'll look at your steps, step 1 says get one side equal to 0. Well, I think it's easier to move 2 terms over here than move 3 terms over here. So I'm going to bring my 3t over, and I'm going to put it underneath my t and make it a negative 3t. I'm going to bring this negative 5 over and put it underneath my 45, and I'm going to make that a positive 5. So I move everything over. That leaves me with the 0. And over here I would have 2t squared minus 20t plus 50. There we go. Look at that. Now, if you'll look at step 2, step 2 says to factor one side of the equation. Well, when I go to factor this, you right away see this 2 and you're like, oh, it's going to be one of these hard ones. Well, hold on. Don't forget. Sorry about that. Hold on one second. Don't forget, you always pull out what's common first. And I see a 2, a 20, and a 50. And I know that 2 goes into all of those numbers. Now, notice I cannot pull a t out because there's no t with this term right here. So I cannot pull a t out, but I can pull a 2 out. So if I pull a 2 out, look what I'm left over with. Watch this carefully. 2 divided by 2 is 1t squared. Negative 20 divided by 2 is negative 10t. 50 divided by 2 is positive 25. There we go. And now look at your trinomial that you're left over with. It does have a lead coefficient of 1, so it is the easy type. So I'm going to list out all of the factors of 25. I'm not going to take time and do that for you, but I would normally list them all out. And these two numbers here are the numbers I'm looking for, okay? Because if you multiply a negative 5 times a negative 5, you get a positive 25. And if you combine those two numbers, a negative 5 and a negative 5, you do get out a negative 10. So you bring your 2 down, put your 2 parentheses, and now the factoring would be t minus 5, t minus 5. Alright, so step 2 said to factor one side, and I've done that. I did that right here. Okay, and so step 3 says now take each group and set each group equal to 0. Now, would you please look at this 2 right here, students? There's no need to take a 2 and set it equal to 0 because there's no t with a 2, and so that's not really any help when it comes to solving for t. But I will take my first group here, t minus 5, and set it equal to 0, and I will solve and t equals 5. Now there's really no need to do that again with this group because they're the same group and you'll just get the same number out again. So the answer is 5. So let's go back a page. Do quadratic equations sometimes have 2 answers? Yes. Do they sometimes have only one answer? Yes. But I did not type this in your notes. I should have. This is something you'd write in your notes. Quadratic equations will never have more than 2 answers. Okay? They will never have more than 2 solutions. So quadratic equations will never have more than 2 solutions. All right, moving on. Again, if you need to pause the video, please feel free to do that. Now, if you'll look at your handout, you're supposed to do page 261, numbers 65 through 79, odd. But I want you to skip 71. That's the factoring that we've not yet learned how to do that I told you guys we're going to have to go back and learn. So skip 71. So that would be 14-7, 8 problems minus 1. 7 problems I want you to work on for a little bit. Now, of course, I know you're saying, well, in normal class, Mr. Earhart, we would work for 10 to 15 minutes and whether we finish would be up to us. I understand that. This is a little different. If you notice, I've given you a small handout because I want you to spend more time working on your homework. I really think it would be extremely unwise to not work all of these problems out. Okay, now that's my opinion. I think you should work them all. If you're going to do as many as you feel like you need to until you understand the procedure, I'm going to allow you to do that. However, you better make sure if you work just some of these that you get down to a problem like number 79. If you'll go ahead and pause the video and turn to page 261 and look at number 79, I mean, that's a killer. That's amazing. And so if you don't do all of these, you better pick and choose wisely. Now, what I'm going to do for you on this video is I'm going to work out 65 through 79 very quickly, okay? And so if you want to fast forward that part and do your homework later, or if you want to do it now, that's up to you. Or if you want to pick and choose your problems, all of that is up to you. But I am now going to very quickly work out these problems in your homework. So I am going to go fast. I'm not going to give a lot of explanation because you can always look at your notes and slow the video down. Okay, step 1 says to get one side equal to 0. I've already done that. Step 2 says to factor. I notice I have a lead coefficient of 1. That's the easy kind. So what two numbers would multiply, give me a -4, -3, these two numbers right here. If you multiply those two numbers, you will get a -4. If you combine those, you'll get a -3. So I'm going to go ahead and factor. And then students, I'm not going to take each group and set each group equal to 0. You can do that on your own. Just trust me, if you take each group and set each group equal to 0, you will get these two answers out for x. Again, I'm going to go faster and faster because you can always pause the video and you can always back it up. All right, number 67. Now, unfortunately, well, first of all, step 1 says get one side equal to 0, and we've done that. Step 2 says factor. Well, unfortunately, students, we're going to have, this is going to be one of the hard ones, okay? We're going to have to factor a trinomial that has a lead coefficient of 5. And so remember, you take 5 times 6, and that will give you 30. And we're going to list out all the factors of 30. However, I'm not going to do that. It takes too much time. I'm just going to say this to you. If you take a positive 2 and a negative 15, you do get, actually that's not correct, is it? Let's see. I don't want those two numbers. That would not work. Let's see here. 6 and 5, 3 and 10. I apologize, students. That's my fault. A negative 3 and a negative 10. If you multiply those two numbers, you will get 30. And if you combine those two numbers, you'll get a negative 13. Remember what to do next? You write your 5x squared, and then you do not write negative 13x. Instead, you put negative 3x, negative 10x. I pick these two numbers up and put them right here, then bring down your positive 6, and we continue to factor. What's common in these first two terms right here? Remember, just totally ignore these two terms, all right? Don't even look at them. Just look at these two right here, okay? 3 and a 5. What goes into 3 and a 5? Nothing. Okay, how about your x's? I have 2 x's here and 1 x here. I can pull 1 x out. So I have my 5, 2 x's here, 1 x here, subtract, you have an x. I have my negative 3, there's 1 x here, 1 x here, subtract, you're left with no x's. Okay, now we look at these two terms. Forget these numbers right here. You don't care about those. Look at these two. What number goes into 10 and 6 evenly? Well, a 2. And can you take an x out of both of these? No, you cannot. So I'm going to pull out, and don't forget, there's a negative sign here with a 10, so I pull out a negative 2. Alright, my two parentheses should match. Let's see what happens. Negative 10 divided by negative 2 is negative 5. Bring down your x. 6 divided by negative 2 is negative 3. And actually I made a mistake right here. See that negative sign? A negative 10 divided by a negative 2 is a positive. That's my fault. So actually, we'll just cross it off. There we go. So do my parentheses match? Yes, they do. So remember what to do. You write your matching parentheses once, and then your other parentheses is what's going to be on the outside, x minus 2. Now if you take each one of those parentheses and set them equal to 0, here are the two answers you would get. You'll get a positive 3/5 and a positive 2. Alright, we're going to move on now to number 69. Number 69. Alright, this should be pretty fast. Looks like a pretty simple problem. Plus 24k plus 144. Again, I'm pretty sloppy here, but you've got it in your book, so you can look at it there. Okay, step 1 says to get one side equal to 0. We've done that. Step 2 says to factor one side. Thankfully, I've got a lead coefficient of 1, so I'm happy about that. I would list out all the factors of 144, which would really take a lot of time. So if you want to stop and just use creativity, you can figure this out. Positive 12 times a positive 12 is 144. When you add them, you get 24. So you could go ahead and write your two parentheses, and your parentheses would be k plus 12, k plus 12. And then step 3, you take each parentheses or each group and set it equal to 0. If you did that, you will get negative 12 for your answer. You're welcome to write negative 12 twice. There's just really no need for that. I don't care. It's just a waste of a time. We are skipping 71, so let's go on to number 73. 73 looks like this. Now this is a very tricky one, so please be careful. Negative 3b squared plus 3b plus 90 equals 0. Now the reason I'm saying it's tricky is, first of all, you want to get one side equal to 0. We've done that already. That's pretty simple. Next, though, we want to factor this side. But please don't forget to always pull out what's common first. And I also taught you whenever that first term is negative, you want to pull out a negative. sign. So I'm going to plot a negative sign plus what number goes into 3, 3, and 90? Well, 3 does. Does every term have a b? No, there is no b with this 90. So I'm just going to pull a negative 3 out, and here we go. A negative 3 divided by a negative 3 is 1b squared. 3 divided by negative 3 is negative 1b, and 90 divided by negative 3 is negative 30. Now I'm going to factor this. Don't you like this a lot better? There's a 1 right here now. That's a lot easier. So let's list out all the factors of negative 30. I'm going to save us a little time. If you have a negative 6 and a positive 5 and you multiply them, you'll get negative 30. If you combine them, you'll get a negative 1. So this factoring is pretty much history. X minus 6, x plus 5. And then we're going to go ahead. If you set each group equal to 0, you will get these two answers right here. All right, it's number 73. Moving on to number 75, and then 77 and 79. So number 75, let's see if I can find that in the book. Here we go. 16x squared equals 8x minus 1. Now, step 1 says to get one side equal to 0. Common sense would say it's easier to move a 16x squared over here and make it negative 16x squared plus 8x minus 1. Please don't do that. Please do not do that. When you do that, you then have a negative first term, and then you got to factor out a negative sign. It really becomes tough. Anytime you can make that first term positive or leave it positive, do that. Okay, so my recommendation to you is to leave the 16x squared where it is, bring the 8x over and make it a negative 8x, bring the 1 over and make it a positive 1. Okay, and now we're ready to roll. Okay, so step 1 says to get one side equal to 0. We've done that. We've moved everything over. Step 2 says to factor, and notice I don't have a lead coefficient of 1, which stinks, but that's just how it is. So 16 times 1, remember you take this number here times this number over here, that gives you 16. And then I've got to list out some numbers. I think this is it right here. If you take a negative 4 times a negative 4, you get a positive 16, and if you combine these two numbers, you get a negative 8. So remember what to do. We bring down the 16x squared. We do not bring this down. We put negative 4x, negative 4x, and then we bring the 1 down and make it a positive 1. Okay, now hopefully you remember what to do from here. We just look at the first two terms. Students, we do not care about these two terms one bit. We look at just these two. Okay, what number goes into 4 and 16 evenly? Well, 4 does. It's the biggest number, and then I can take 1x from both of those. So I'm going to go ahead and pull a 4 out and an x out and put my parentheses. 16 divided by 4 is 4, and 2 minus 1x gives you an x. Negative 4 divided by 4 is negative 1, and of course there's no x. X minus x leaves you none. Now, all I want you to do is just look at these two terms right here. What number goes into 4 and 1? Well, just a 1, and there's no x you can pull out. Now that first term is negative, don't miss that. So the only thing you can really pull out is simply a negative 1. That's all you can pull out. But when you do that, you will get 4x minus 1. Watch carefully. Negative 4 divided by negative 1 is 4 with an x. 1 divided by negative 1 is negative 1. So look at that. Your parentheses did match. So now you have 4x minus 1, and then the other parentheses we write what's on the outside, so 4x minus 1. And that will happen sometimes. So now if you take each group and set each group equal to 0, you will get 1/4 for an answer. You'll get the same answer for both of those. If you want to write 1/4 twice, I really don't care. There's no need for that, but that's fine. Okay, moving on to problem number 77. All right, here's the problem. Okay, right out of your book there. So hopefully I've copied that correctly. All right, students. Well, you know what step 1 says to do. You want to get one side equal to 0. So I'm going to bring the negative y squared over and make it a positive y squared, and bring this positive y over and make it a negative y. If you do that correctly, you'll be left with this right here. If you didn't get that, please correct your mistakes and understand, make sure you know what to do. Okay, continuing on, step 2 says to factor one side. I wish I didn't have this 3 here, but I do, so I'm going to multiply. I've got to factor this side over here, so I've got to multiply 3 times -8. That gives me a -24. And then let's see, what factors would I have? How about this? How about a negative? How about a +3 and a -8? That would work. If I multiply those, I get a -24, and if I combine those two numbers, I get a -5. So remember, we don't have a lead coefficient of 1, so we bring the first term down. We don't bring the -5 down. We bring down the +3y, and we bring down the -8y, and then we bring down the -8. So there we go. Now, I keep drawing this into your head. Don't look at these two terms. We don't care about these two terms. All that we care about are these two terms right here. What number goes into 3 and 3? Well, 3 does. And you have 2 y's here and 1 y here, so you can pull 1 y out. So I'm going to go ahead and pull a 3 out and pull a y out. And let's see what we're left over with. 3 divided by 3 is 1. You have 2 y's minus a y, you're left with a y. 3 divided by 3 is 1. And then of course your y's minus a y, there's no y's left. If you don't want to put that 1 right here, you don't have to. If you want to, you can. Okay, now let's look at, forget these two terms. Now just look at these two terms. Nothing else but these two. What number goes into 8 and 8? Well, 8 does. And is there a y in both terms? No, there is not. And so we're going to pull an 8 out, but hold it. Notice this 8 here is negative, so we're going to pull a -8 out. And let's see what happens. Our two parentheses should match. -8 divided by -8 is 1, and then bring down your y. And then -8 divided by -8 is 1. So yes, our parentheses match. So you would write your matching parentheses once, and the other parentheses would be what's on the outside, which is 3y. And that should be a minus sign. Hold on one second. 3y minus 8 equals 0. Now, if you take each group and set each group equal to 0, you will get -1 for one answer, and you will get a +8/3 for the other answer, or 2 2/3, or 2.6 repeating. Alright, that's number 77. I'm having doubts now about doing number 79, to be honest with you. We haven't gotten into squaring a binomial. You should have had that in Algebra 1, but since I haven't had you guys for Algebra 1, and I know, Chase, you said your Algebra 1 might have been a little weak, I really don't know how much I want to get into. I guess I'll do this very quickly. You can skip the problem or watch. That's up to you. I don't think I'll give you one where you have a parenthesis squared like this, but real fast, that means w plus 6 times w plus 6. And of course over here we know we have 3w plus 36 minus w squared. And now when you multiply a binomial times a binomial, it's w times w, which is w squared, w times 6, which is 6w, 6 times w, which is 6w, and 6 times 6, which is 36. Now, we've not learned that, so if you're lost there, you're totally normal. Don't worry about it. And then, of course, you want to get one side equal to 0. So I would bring the w squared over negative and make it positive. That's 2w squared. So I'm going to cross those off. I'm done with those two terms. Let's see, I've got a 6w and a 6w. That's a 12w. Bring the 3 over and make it a -3, and that would be a positive 9w. So I'm done with that, I'm done with that, and I'm done with that. And then bring the 36 over and make it a -36, and that gives you 0. It cancels out, so you're left with just that. Now right away, probably what you would say is, oh, it's not a trinomial, what am I going to do? Well, don't panic. I mean, you do know that the first thing you always do is pull out what's common. So I don't know of any number that goes into 2 and 9 evenly, but I know I can pull a w out. I've got 2 w's here, I've got 1 w over here, so I know I can pull a w out. So I'll pull a w out, and you're left with w. 2w's minus 1 is 2w plus 9. Look at that, that's not too bad. And now if you take two groups, take this group right here, W, take W and set it equal to 0. That's one answer. And then take 2W plus 9, set it equal to 0. And you get negative 9/2 or negative 4.5. I won't give you one that hard on a test or a quiz, at least not right now, but that's quickly how you do that. So, okay, moving on. If you're hopefully still awake, at least one thing about the the video class like this, you can pause it and take a break if you need to. Okay, moving on. Okay, please turn in your handout to page 2, page number 2, and it says solving quadratic equations by the square root method. All right, now I can only tell you what's important. I can't make you learn it, but I'm telling you right now, this next sentence there on your handout, you can read it to yourself as I read it aloud. This sentence is very, very important, and that's why it says very important. And here's what the sentence says: this method only works, this method being the square root method, of course, this method only works if, after you have simplified the equation, there is no x term. Maybe next to that sentence you should write an example of what I'm talking about. X squared plus 5 equals 0. That is a quadratic equation that does not have an x term. Once you go ahead and write that down and put, actually I'd put does not if I were you. I would put does not have x term. Okay? All right. And that's what I'm talking about when I say it does not have an x term. It has an x squared term and it has a constant term, but it does not have an x term. Students, you cannot use the square root method on a quadratic equation that has an x term. The only time you can use the square root method is when the quadratic does not have an x term. Please don't forget that. Okay, so with that in mind, let's get after it. I'm going to read the steps out loud, and you can follow along if you would like to. Step 1 says simplify both sides of the equation as far as possible. Step 2, make sure there is no x term. If there is an x term, then you cannot use the square root method. You'll have to use another method, like factoring, like we just learned. Step 3, isolate the x squared term. Step 4, take the square root of both sides. Be sure and put a plus minus in front of the radical. Okay, let's get after it. I'm going to walk you through this step by step by step. So here we go. Okay, because I have given you a little bit of a longer assignment, page 267, 51 through 59, we're going to go ahead and use those for our notes. So you might want to pause the video and go ahead and turn to page 267 and look at number 51. Okay, so we're actually using these for our notes. So here we go. Let's take a look at number 51. All right, now again with this homework, I think in this case you should work all of the problems, because if you look at number 59, that looks ridiculously hard compared to number 51, and I'm telling you, you need to know how to solve these equations. Okay, but again, I treat you somewhat like college students. It's your decision, but you're responsible to know how to solve these equations. All right, let's take a look at number 51. We're kind of doing our homework at the same time we are taking notes. X squared equals 121. Are you ready? Let's take it step by step. Step 1 says to simplify both sides of the equation. You cannot simplify this side and you cannot simplify this side. So on to step 2. Step 2 says make sure you do not have an x term. You do not have an x term. I have an x squared term and I have a constant term, but I do not have an x squared term. Step 3 says to isolate the x squared term. That means get the x squared term all by itself. Well, students, that's already done. We're down to step 4. X squared is all by itself. I don't see anything else over here on this side with the x squared. So we have isolated the x squared. Step 4 says take the square root of both sides. So we have an x squared. We can take the square root of x squared as long as what we do to one side, we do to the other side. And notice on step 4 in your notes it says don't forget to put plus minus in front of this radical. That's very important that you do that, okay? So I take the square root of this side, the square root of this side, the square root of x squared is x, and the square root of 121. Are we going to solve that, or are we going to simplify it? Well, you tell me. Is that a perfect square? Yes, it is. So because it's a perfect square, we are not going to simplify it, we are going to solve it. And so I bring down my plus minus, and what is the square root of 121? 11. Remember, when you solve a radical, the square root is gone. The radical is gone. So there's your answers. So this quadratic equation has two answers, plus, minus 11. All right, let's pick up the pace a little bit, and let's try number 52. We're doing all of these, not just the odds. So number 52. Okay, just like the last problem, x squared equals 90. Step 1, simplify both sides. We can't do anything. Step 2, make sure you don't have an x term. You don't. Step 3, isolate the x squared term. It's already isolated. And step 4, take the square root of both sides. So the square root of x squared, and then don't forget your plus minus square root of 90. Now this problem here is a little different. The square root of x squared is x. That's fine. But 90 is not a perfect square. But students, we know a perfect square that goes into it. So we can't solve it, but we can definitely simplify it. So 90 is the same thing as 9 times 10. Okay, then cross off the 9 and put a 3 on the outside. So x equals, your plus minus comes first, then the 3, because remember the square root of 9 is 3, and then 10. And that's how I would like you to write your answer. I do not want decimal answers. I want radical answers for these. All right, continuing on to number 53. We're going to pick up the pace down a little bit, so let's go a little faster. All right, number 53. 3x squared equals 108. 3x squared equals 108. Step 1, simplify both sides. I have. Step 2, make sure you don't have an x term. I don't. Step 3, simplify, or excuse me, isolate the x squared. Well, there's a 3 right here that I need to get rid of. And so I'm going to divide both sides by 3. And x squared equals 36. 36. 108 divided by 3. And now step 4 says take the square root of both sides. So we'll take the square root of x squared, and then plus minus square root of 36. The square root of x squared is x. And now ask yourself, am I going to solve or simplify? Is 36 a perfect square, or is it not a perfect square? Well, it is a perfect square, so the radical's gone, and I'm going to solve it, and that is my answer. All right, let's move on and take a look at number 54. Number 54. All right, number 54 is 2x squared plus 5 equals 41. Good problem. Building up little by little to harder and harder problems. Step 1, simplify both sides. Well, you cannot simplify this side. They're unlike terms, and you cannot simplify that side. Step 2 says make sure you don't have an x term, and you don't. Step 3 says isolate the x squared. So the first thing I'm going to do is subtract 5 from both sides, and when I do that, I'm left with this. Then I divide both sides by 2. When I do that, I'm left with this. Now I take the square root of both sides. Square root of x squared, square root of 18. That's step 4. Well, the square root of x squared is x. Now, the square root of 18, ask yourself, is 18 a perfect square? No, it is not. So I'm not going to solve this, but I am going to simplify it if at all possible. And it is possible. Do I know of a perfect square that divides into 18 evenly? Yes, 9. 9 times 2. And now I simply cross off the 9. Remember, your plus minus comes first. And then cross off the 9. That's a 3 on the outside, with the 2 left over on the inside. So we're moving pretty quickly here. Let's take a look at number 55. Again, I go fast. You can slow me down by pausing the video. Negative x squared minus 12 equals negative 87. All right, step 1 says to simplify both sides. I can't simplify that side. I can't simplify that side. Step 2 says make sure that you don't have an x term. I don't. Step 3 says isolate the x squared. So I'm going to add 12 to both sides. And my computer's kind of messing up here. Hold on one second. All right, add 12 to both sides, and you will get this right here. All right, use a calculator if you need to. Now, the x squared is still not isolated. There's a negative sign here. Really, it's like having a negative 1 right there. So now I've got to divide both sides by a negative 1. So x squared equals 75. And now we take the square root of x squared one side, but we must also take the square root of the other side. All right. And so here we go. Square root of x squared is x, and 75 is not a perfect square, so I cannot solve it, but I might be able to simplify it. I'm thinking of this, 25 times 3. 25 is a perfect square, and 25 goes into 75 evenly. So x equals, your plus minus comes first, then the square root of 25 is 5, and then 3 left over on the inside. All right, and let's continue on. Let's take a look at number 56. Number 56. Now, if you want to skip some of these and you really think you're doing well and go on to number 59, that's up to you. I am giving you that leeway. Be wise in your decisions. Okay, step 1 says to simplify both sides. Can't do anything. Step 2 says make sure you don't have an x term, or in this case a u term. We don't. And then next we isolate the u squared. So now be careful here. This is a positive 7, not a negative 7. So I'm going to subtract 7 from both sides. That's the first thing I do. Subtract 7, they cancel. Subtract 7 gives me negative 6. Now I divide both sides by a negative 10. Be very careful. I don't want a decimal. No decimals allowed. So we're going to divide by negative 10. A negative 6 divided by a negative 10 is a positive 3/5. Now your calculator will do this for you. Listen to me carefully. If you'll type in negative 6 divided by negative 10, enter, and then hit math, enter, enter, it will give you 3/5. Let me go over that again. If you'll type in negative 6, now don't use the minus sign, use the negative sign. Negative 6 divided by negative 10, enter, and then math, enter, enter, you will get this, okay? All right, continuing on. Now let's take the square root of both sides. So the square root of u squared equals plus minus the square root of 3/5. Oh, look at this, look at this, look at this, look at this. We spent a whole class period on those. Yeah, that's why we did that, because now we got to do a bunch of work to this. Okay, the square root of u squared is u, and you're left with this answer right here, and that's no good. Remember what I taught you last week? Or earlier this week on Monday, you do not want to have a radical in the bottom, so we got to do some work on this thing. First of all, we have square root of 3 over square root of 5. We split it up. And then remember what to do. We multiply the top and the bottom by the square root of 5 over square root of 5. All of this still equals u. U still equals all of this. We're just simply simplifying this side over here. So I get out square root of 15 over square root of 25. So your final answer then is, are you ready for this? Square root of 15 over, what is the square root of 25? That's a perfect square. We can solve that. 5. That, oh, what did I forget to put in front of this? That's totally wrong. Don't forget your plus minus. Got to put the plus minus. Now how do I know I'm done? Well, there's a 1 in front of this radical even though you can't see it. Okay? And so I can't reduce my outside numbers. This is a 15. I don't know of any perfect squares that go into 15 evenly. And there's really nothing else I can do to this. Okay? All right, let's move on to number 57. Number 57. We're just about done. 3 more of these, and I'm actually going to take a break here. I'm going to go ahead and I think I'm going to take a break and make another video for you guys to watch for the last part of your notes. My voice is getting a little tired talking straight through like this. Okay. All right. Step 1 says to simplify both sides. Really nothing you can do. Step 2 says make sure you don't have a v term, and we don't. And then step 3 says isolate the v squared. Well, if I'm going to isolate the v squared, the first thing I'm going to do is add 1 to both sides. So I will get 12. Now, think about this. If I had 25v squared equals 12, these two are multiplying, and the opposite of multiply is divide. So I would divide both sides by 25. We know that. We've done that many times. Well, what is the 25 doing to the v squared? Isn't it dividing? Well, what's the opposite of divide? Multiply. So let's multiply both sides by 25. If we multiply this side by 25 right here, the 25s would cancel out, leaving you with v squared. And if I multiplied 12 by 25, I'm not sure what you would get. 240 plus 60, 300 I believe is correct. Yes, 300. Okay, so I multiplied both sides by 25. And now I take the square root of v squared and the square root of 300. Is 300 a perfect square? No, it is not. But I can simplify that thing most definitely. 100 times 3. And then, of course, your final answer would be plus minus, what's the square root of 100? 10 square root of 3. All right, let's move on to number 58. Number 58. 2 more problems, all right? And then we'll take a little break. I'm going to go ahead and take a break myself, and you can take a little break and watch another video later, okay? Or right away if you choose to. All right. Step 1 says to simplify both sides. There's really nothing we can do. Step 2 says to make sure you don't have a p term, and we don't. Step 3 says to isolate p squared. So we're going to isolate it. Well, the first thing I would do, now this 6 is a positive 6, so I would subtract 6 from both sides. That leaves you with negative p squared over 8 equals negative 10. Now what did I teach you over here? If these two right here are dividing each other, if they're dividing, the opposite of divide is multiply. Okay? So it looks like these two are dividing, so the opposite of divide is multiply. I'm going to multiply both sides by 8. Multiply both sides by 8. Now when you do that, you're left with negative p squared equals negative 80. Alright? And now you don't want that negative sign there, so divide both sides by a negative 1, and you're left with p squared equals 80. Alright? Now let's take the square root of p squared, and the square root of 80. Is 80 a perfect square? No, it is not. So I can't solve it, but I can definitely simplify it. So I would have this. 4 goes into 80, and 4 is a perfect square. But if you use 4, you have to use 4 again twice. I'm going to go with the biggest number, which is 16. 16 times 5 is 80. Okay? And 16 is a perfect square. So my final answer is, put your plus minus first, cross off the 16, put a 4 on the outside, and a 5 on the inside. Now you can see why last class period, I'm not the smartest teacher in the world, but I definitely had a reason why I taught you first how to simplify all of these radicals, because I knew we would need that in these equations. Okay, and then last but not least, if you're barely somehow still awake, miracle of all miracles, this is our last problem. Okay, so here we go. 5q squared over 6 minus q squared over 3 equals 72. Now students, look, I mean, I can't give you steps that help you conquer every single equation. There's going to be little curveballs that can be thrown at you. I think this problem would be a lot easier if we could just eliminate our fractions. I really, really do. And I notice that I have a denominator of 6 and a denominator of 3. Now we learned this back when we were solving multivariable equations. You might not remember this, but we did. We learned how to eliminate fractions, okay? And what we said is you multiply the entire equation by whatever the bottom of the fraction is. And of course, when I say that, you're like, well, Mr. Earhart, there's two denominators. Which one do I use? Well, you think of a number that 6 and 3 will both go into evenly. Well, that's obvious. 6, right? I mean, 3 goes into 6 and 6 goes into 6. So, I'm going to multiply. Now watch how I do this. Please watch carefully. I'm going to multiply the entire equation by 6 over 1. Alright? Now watch what happens. 6 over 1 times 5q squared over 6. Your 6's would cancel. And that would leave you with 5q squared. Now, I'm going to take 6 over 1 times q squared over 3. Notice your 3 would cancel into your 6 2 times. And you're left with 2q squared. Now, you can't multiply this by 6 and this by 6 and not multiply this by 6. You have to multiply every term by 6. So 6 times 72 would be 2, carry 1, 432. So I multiplied everything by 6, and you know what? This is a lot easier. Now look what you can do with these two squared terms. 5q squared minus 2q squared is 3q squared. And now you're ready to isolate the q squared, so divide both sides by 3. Goes in once, 144. And then, of course, take the square root of both sides. So you take the square root of q squared equals plus minus the square root of 144. Now, this is a perfect square right here, so we are going to solve. There'll be no radical left. Q equals plus minus 12. And my voice has just about had it. I have talked straight through now. I'm not sure for how long it's been. So there'll be another video for you to watch for the rest of the lesson, which is going to be, if you'll look at your handout and look at the middle of page 2, it says writing quadratic equations in intercept form, and we'll be tackling that in the next video. All right, hope you guys are doing well and knocking your homework out and getting this stuff done.